I have my Post-it notes that I'm going to use for my rough drafts. And then we're going to get started. Before we really super get started, though, let's remember this segment addition postulate. The SAG, if you will. The segment addition postulate says if you have something like A, B, C, the segment addition postulate says that you could do A plus B, A, B plus B, C equals, I guess we should say, is congruent to AC. In other words, I'm allowed to say that that segment plus that segment equals the whole segment. That's the segment addition postulate. We're going to probably use that quite a bit. Okay, so it's there. Hooray, hooray. I have to prove the following. I have to prove WX is congruent to, well, I have that WX is congruent to YZ. So I'm going to make my little rough draft over here. Okay. I have WX is congruent to WZ, which means WX is equal to YZ, not WC. WX is equal to YZ. What I'm going to try to do is connect WX to WY somehow. So let's do that now. There's WX. WY is that whole chunk. So WX plus XY is WY. So I'm going to say that. WX plus XY is WY. Okay, what did I do? The segment addition postulate. What did I do up here? I did the definition of congruence. All right, so I have Y. So for those of you who are not sure what I did, my first step is going to turn those lines and congruence and stuff like that into equal signs. And the reason why I'm allowed to do that is the definition of congruence. Then what I did is I thought, how can I turn WX into WY? Well, WX plus XY is WY, so I said that. Similarly, how can I turn YZ into XZ? There's YZ, there's XZ, so I could say YZ plus XY, YZ plus XY equals XZ. And that's also the segment addition postulate. Look. These two guys have an XY in common. Why don't I get it so that I have XY all alone on the left? So if I subtract WX from this side, if I subtract WX from that side and subtract YZ from that side, I will have XY all by itself on the left. The majority of these types of problems, what we're going to end up doing is set things equal to each other, find out that things are equal in some way, maybe do a little substitution, maybe do a little bit of disappearing, and hope that you end up with what you have at the end. And that's what's probably going to happen here. So if I subtract WX from the first one, I get XY equals WY minus WX. I said minus WX from both sides, and that gave me that. From the second equation, if I subtract YZ from both sides, I have XY equals XZ minus YZ. How did I do both of those? Subtraction property of equality. Now that YZ equals this, and YZ or XY equals this, and XY equals that, I can say they're equal to each other. So I can say WY minus WX, that guy, is equal to XZ minus YZ, that guy. And that's a transitive property. Whenever you say something equals this and the same thing equals that, and you make them equal to each other, that's transitive property. Looking at my proof here, and looking at my given, and WX and YZ are the same thing. So if WX and YZ are the same thing, I'm just going to turn that wx into yz. wy minus yz equals xz minus yz. And that's a substitution property of equality. Substitute. If I add yz to both sides, I get wy equals xz. And that's what I want. Sicka, 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 sicka. I'm just pretending to be a rap musician, that's all. I like to have fun. I like to have fun. I like to have lots of fun. All right. Yes. XD is right. Statement. Reason. Statement number 1 is my given. Wx is congruent to yz, and that's my given. I need to say that if wx is congruent to yz, although it's redundant, I need to then say that wx equals yz. It's just one of those things that you have to do. That's the definition of congruence. Then what I did is I used the segment addition postulate, and I said that wx plus xy equals wy. I also said that yz plus xy is xz. And again, that was the segment addition postulate. I noticed that xy and xy were in common with both of these guys, so I figured, well, why don't we remove wx and why don't we remove yz to the other side so that I can have xy equals this and xy equals that. So when I did that, I ended up with xy equals wy minus wx, and I also had xy equals xz minus yz, and I used the subtraction property of equality. Oh, look, xy equals this thing, and xy equals that thing. Set them equal to each other. That's what I did here. Wy minus wx equals xz minus yz. And the reason why I'm allowed to do that is the transitive property of equality. Then what? Well, I turned wx into yz because I noticed if I had a yz on the left and a yz on the right, then things would cancel out. And I'm allowed to do that because wx is yz, says statement 2. So 6 is wy minus not wx anymore, yz, equals xz minus yz. And that was using the substitution property of equality. You know, I have so many pens that I could write out equality in all these different colors and it would make sense. But, you know, I don't have time. I don't have time because, as you may have noticed, these proofs, they take a long time. Well, if that's the case, and if I have a negative yz on the left and a negative yz on the right, then they cancel each other out, and that leaves me with wy equals xz. And the way that I would get rid of the negative yz was I would add yz to both sides. So I use the addition property of equality. And now that I've said that, I can end things out by saying segment WY is congruent to segment XZ. And just like I did here to get from 1 to 2, the way I get from 7 to 8 is the definition of congruence. Whew. And I'm not going to pretend like I heard a dog, but whew, that's rough. Yep. So pretty much the general theme behind this problem is we were told something equals something. And so I ended up saying this plus that equals this, and this plus that equals that. And oh, look, these guys are the same, so we can get rid of them. And if those guys are the same and we can get rid of them, then we end up getting what I want. It is a lot. And it's crazy. Oh, it's what's even crazier is I have this smudge there that I have to look at now. Oh! Let me erase it. Nope. Just so we could see a little bit better, I'm going to move this closer to that while I make my rough draft. And then I'll zoom back out again. Okay. So if if segment SC is equal to HR, okay, so SC, if SC is congruent to HR, and HR, nope. Hey, speaking of SC, Santiago. It's your initials. HR is congruent to AB. AB, I have 6 of those. SCA, look, Santiago, it's really your initials. Boy, it's your lucky day. All right, so I need to prove that SC and AB are the same. This is almost too easy. All right, so simply put, I'm going to say SC equals HR. I'm going to write out 1 is my given. SC equals HR by definition of congruence. Also, so anytime I do definition of congruence, I'm going to put just the star. Definition of congruence says that. Definition of congruence also says that HR equals AB. Look. If SC equals HR and HR equals AB, then SC equals AB. I don't have to say anything. Scab. And that's what I have to find. So then I could say SC is congruent to AB. So this is going to be easy. Oh, that smudge. I don't like it. That cord's in the way. Oh, God, I'm just a mess. Let me put that guy there so I can do what I need to do. I have my statements. I have my reasons. And always, my first statement is my given. So it really didn't give me my proof as like the last one. The first one just said, given blah, blah, blah. Mine is an if-then. Mine's a conditional statement. So the if part is going to be my given, and the then part is going to be my prove. So if segment SC is congruent to segment HR, homeroom, and HR is congruent to angle segment AB, I have 6 of those. That's going to be my given. What I wrote out here first is, well, that just means that SC equals HR and HR equals AB, and that's because of the definition of congruence. The definition of congruence, sing it with me, definition of congruence. It tells us that segments are equal. If SC equals HR and HR equals AB, that's the transitive property. Thank you. So I can now say SC equals AB. And then I said scab, and then I laughed. What did I say? Transitive property. Oh my gosh, I misspelled that terribly. Of equality. And then I'm done, baby. I'm done. Segment SC is congruent to segment AB by definition of congruence. Why couldn't we have started out with that one? Why did we have to do that 8-stepper up there instead of doing the 4-stepper first? Why did I have to do that to you? Because I'm mean. Keep that hanging on my wall. I'll probably take a picture of it and post it on the gram. Prove. Let me see. This is a funny angle. All right. So a lot of these problems, again, are taking what I'm given, literally, and trying to connect it to the end. And how can you do that? And what can you say to each other to make that work? So looks like we're going to have to do a little bit of math here. CD, or E is the midpoint of DF, and CD is the same as FG. So I have, if E is the midpoint of DF, then I know this guy is congruent to that guy. So I can, my first step after my given is I can say, well, let me say this first because I feel like I should go in the order. I'll write out my given. That's going to be step 1, given, blah, 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 blah. Step 2 is I will say CD equals FG, and that's the definition of congruence. By definition of midpoint, I can say that DE is equal to EF. Okay, and that's the definition of midpoint. In the end, I want CE equals EG. So let's try to find a way to connect CE with what I have here. All right, and then I'll connect EG with what I have up here. So I have CE, this is step 4. CE is CD, oh good, I have that one, CD, plus DE, oh good, I have that one. And then I have to prove something involving EG. So I could say EG equals EF. Oh, look. Plus FG. Oh, look. And that's the segment addition postulate. So I need to show that these two guys are equal. So I'm thinking if I could show that this two and these two are the same exact thing, then I could show that those two guys are equal. Why don't I take CD and replace that with FG? So I'm going to take this top equation and say CE equals CD is FG, DE is EF. And look what I just did. I just showed that EG is EF plus FG and CE is EF plus FG by doing substitution. And if you're like, whoa, what just happened? What I just did is I need to show that these two are the same. So if I can show that these two are the same, then I can prove that these two are the same. So I took the top equation, I turned CD into FG, substitution, and I turned DE into EF. And so I have EG equals EF plus FG, and I have CE equals EF plus FG. So, and this would be 5. Well, actually, I guess this would be 5. 6 would be that they're now equal to each other. CE equals EG, and that's the transitive property. And step 7 would then that final thing that I always seem to have to say, which is that. And that's what I'm trying to prove. And boom, 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 boom. And that's the definition of congruency. All right, so there I have it. Again, what I did is simply put, I have to prove that this guy and this guy are equal to this guy and this guy. Since these two are equal and these two are equal, if I just say, well, look, this is the same as that and this is the same as that, which means everything's the same thing, then I've done it. I just have to write it out in this awful format. So let me put that there where you can see. Let me make a proof statement. Reasons. Statement number 1 is always my given. E is the midpoint of segment DF. Also, CD is congruent to FG. CD is the same as FG because of that guy right there. CD is the same as FG, definition of congruence. DE is equal to EF by the definition of midpoint. Using the segment addition postulate, I was able to say that CE equaled CD plus. Let's write it out this way. No, too late. I already set that up. CE was equal to DE. What I'm going to do is I'm going to write that one EG. I'm going to write it out as FG plus EF. And if you're like, why, you'll see. It's the same thing. That was the second edition postulate. What we discovered is that CD is the same as FG. So if I rewrite this top one out, instead of saying CD, I said FG. And instead of saying DE, I said EF. Then I can immediately notice that, oh, look, these two guys are the same exact thing. But first I had to do a little bit of substitution. So since EG is the same as FG plus EF, and CE is also the same as FG plus EF, then EG equals CE. That's the transitive property. And if I say EG equals CE, then I'm allowed to say EG segment is congruent to segment CE. And that is the definition of congruence. Last one. B is the midpoint of AC. So B is the midpoint of AC, which means A, B, and BC are the same thing. Wondering. D is the midpoint of CE. So these two guys are the same thing. AB and DE are the same thing. So this guy right here and this guy right here are the same thing. All right, so let's, given. By definition of midpoint, I'm allowed to say that if B is the midpoint of AC, then by definition of midpoint, AB and BC before Christ are equal to each other. Wait, AB? I have 6 of those. D is the midpoint of CE, which means CD and DE are the same thing. And that's all the definition of midpoint. If AB, so all right, so what I set up here is that I said that AB is congruent to DE. So if AB is congruent to DE, that is by definition of congruence. I should be able to say, well, let's do this. Let's see if we can be cute here. Let's see if we can be cute. My job is to show that AE equals 4A, or AE equals 4AB. So let's do this. Let's use the segment addition postulate and say what AE is. AE equals AB plus BC plus CD plus DE, and that's the segment addition postulate. I want them all to be the same as AB. So I'm going to do a lot of substituting. Since BC is the same as AB, well, first off, AB is AB. Let me just write that out quick. BC is AB. DE, oh, I'm not there yet. DE is also AB. And you know what I should have put in between? CD is equal to AB. So this is actually going to be step 6. And step 5, I should have said that CD equals AB. If DE equals CB, and if DE equals AB, then CD equals AB, and that's the, what is that, transitive property. So CD became AB. So AE equals AB plus AB plus, oh, AB, my bad, plus AB. And so step 7 is going to be AE equals 4AB, because I can just combine like terms. Okay. All right, you ready? My given is B is the midpoint of AC. D is the midpoint of CE. AB is congruent to DE. That's my given. Since B is the midpoint of AC and D is the midpoint of CE, I can split AC and CE in half. All right, so that's what allowed me to say AB equals BC and CD equals DE. Definition of midpoint. Definition of midpoint. It sounds like I'm trying to start a card. Stupid. Oh, 4 minutes. 3 is if AB is congruent to DE, then AB equals DE. Remember, I found out that, 4. I didn't even get to 4 yet. Why don't I do this? Why don't I put 5 before 4? So I'm going to put CD equals AB. And that's because CD equals AD. AB also equals CD equals DE. AB also equals DE. So the transitive property says that, well, look, if DE equals this and DE equals that, then the transitive property says they're just equal to each other. AE equals AB plus BC plus CD plus DE. Whenever you add a bunch of segments to get a new segment, you use the segment addition postulate. By the way, the next thing you're going to learn is the angle addition postulate. And yes, it's basically the same thing. AB is AB. Remember, we want AB in the end. AB is AB. BC is AB. CD is AB. DE is AB. And I was allowed to do all that substituting because I used the substitution property of equality. And last time I checked, ladles and jelly spoons, last time I checked, AB plus AB plus AB plus AB is 4AB. And that's because all I have to do there is combine like terms. Done. Done, and with a minute to spare. Done, and with a whole minute to spare. So much is right, kids. So much is right. It's just not right. Except that we write a lot.